In this example, I'm going to create a beam where one end is a point load on another beam. I'm then going to design the second beam, assigning the first beam as a point load, and then complete the first beam. From the plan shown here, we're going to create a beam above the lounge, SEO1. This beam is 4.8 meters long and is supporting a floor load. Because the floor joists are perpendicular to the beam, the span being supported is the distance between the two load-bearing walls, which is 5.2 meters. End 1 is supported on a 2.6 meter high post, which lands on an internal pad foundation. End 2 is landing as a point load on a beam supporting the second story, element SEO2. This second beam is 5.2 meters long and is supporting two roofs, an upstairs wall, a portion of a floor that is parallel to the beam. The point load is located in the middle of the beam at 2.6 meters. End 1 and 2 are both supported on posts, which land on the external two-story foundation of the house. Let's start by designing beam 1, the beam over the lounge. Start by designing a beam supporting a floor. Enter the dimensions and a label. The floor span is 5.2 meters. Save the beam information. There are no point loads, so show the available members. Select and save your required member. In this case, I've chosen a 200 PFC. We can now design the end connections for member 1. End 1 is an engineered post 2.6 meters high. I've chosen a double stud and I'll choose an appropriate connection detail. End 2 is going to be a point load, so instead of connecting it to an engineered post, I'll select that End 2 connects as a point load on a to be confirmed beam. I'll then save the end connections and I'll use the crumb trail at the top to jump back to design my supporting beam. We'll complete this beam once the point load has been assigned. Let's now create the beam under the second story wall. Again, I'm designing a beam and it's supporting two roofs, a wall and a floor, 5.2 meters long, and I'll enter the supported elements. The upper roof has a 4.6 meter span with a 600 mm eave overhang. The lower roof has a 1 meter span. The upper wall is 2.4 meters high, and as the floor joists are parallel, the spacing is 600 mm. I'll save the beam information. I can now assign the point load. Click Manage Point Loads and then New Point Load. From the point load list, select the beam over the lounge, End 2. This is located on the back span at 2.6 meters. Save the point load and return to the structural element screen. You'll see a note explaining the design of the element is being governed by the deflections of the element that is supporting. This can be closed. Show the available members and select your option and save. I've chosen a 250 PFC. I'll now design the end connections for this beam. They're both the same, so I'll choose Make End 2 the same. I'll select a 2.6 meter high post and I'll choose an appropriate detail. I'll then save the end connections. I'll now design the base connections. Again, both can be the same as they land on the ribs supporting the external two-story foundation. I'll choose an appropriate detail and save the base connections. The design beam is then shown, and this schematic shows the point load is in the middle of the beam. I'll return to the structural elements to complete beam 1. Select beam 1 and choose the End Connections tab. You'll now see that End 2 is a point load on structural element 2, the 250 PFC. I can now select an appropriate connection detail for that. I'll select the detail that aligns the beams at the top and I'll save the end connection. My last step is to design the base connections. So I select an internal pad foundation for End 1 and choose an appropriate detail. Note that End 2 doesn't have a base connection as it's a point load on another beam. The completed beam is shown, detailing the fact that End 2 is a point load. I'll return to the structural elements and you can see I now have two completed beams. Congratulations, you've just successfully created a beam that point loads onto another beam.